to today's proceedings, I give you pedals!
Sorry, it's underneath the touch of whack.
Hi everybody, we're Team Pedals, and today we're going to be presenting our final project to you all. I'm Steph, this is Caitlin, Neil and Nick, and our teammate Anna couldn't be here with us today, but she's contributed a lot to this project as well. So to start off, I'm going to talk us through the inspiration and idea behind our app. Then we'll do a demo, then we're going to run through our tech stack, challenges and the development. So what is Pedals? Pedals is a web app where users can draw and plan their own cycle routes. The initial idea was brought up when Caitlin pointed out in our brainstorming that there aren't many apps where cyclists can plan their routes when they won't be optimised to a quicker route and we don't have to travel down set roads. So for cyclists, this obviously isn't ideal. It's not about the quickest route from A to B, but the route they take to get there. So we wanted to really build on this idea and make it a more interactive experience for users and also make it a bit social as well. So to do this, we allow users to pin attractions, warnings and food and drink recommendations along the route. They can then save this, share this with others, and they're also able to access other people's routes and review these as well. So next, Nick is going to take us through a demo of our app.
Thank you. Cheers, Steph. Okay, so we start off and we've got the home page where it's got all the instructions on how to use the app. And then if you click Get Started, it goes to the login page where we can log in as not Jess Jelly. Didn't see that coming, did you? And then we head over to the Draw Route page, and in the top left, we've got the controls. It uses current location to find the location, and then over to the right, it's got the distance and the elevation and other stats there, which you can see changing as we draw the route. And then if we want, we can pin any attractions or warnings on there, any food or drink places. In this case, we're just going to put a warning down: beware of the angry geese screaming at you whilst you're on the canal. And then we can come along with any, if we want to put the route type in there, and then the route name and description, and then we can save the route so that other people can view it. Then we can check out the different route categories. So if we go on that, and there's a sort by function, and we can look at the static images on the page, and then each card has a sort of route information on there. We pick one that we like. And then over to the right, you can see the elevation graph, which shows, like, as it goes along, the change in elevation. We've got the total elevation change. We've got any attractions and warnings on there. We can leave a review if we like, good or bad. This one's a fantastic route, so we're going to leave a good review, obviously. And then if we really particularly like the route, we can save it to our favourites. And then if we head over to the profile page, it's got any routes that we've drawn and any favouted routes that we've decided to save in there as well. And that is our app. I'm going to pass you to Caitlin, who's going to talk about the tech stack that we used.
Thank you, Nick. So for our backend, we built this using JavaScript and Express. We had a lot of experience with this throughout the course, so we knew what we were working with there. It really allowed us to get our backend up and running quickly so we could focus on the front end. We also used MongoDB for our database. We chose a NoSQL database because we knew that the map data would be in GeoJSON format. So it allowed us to, we didn't have to structure the data that we put in, and we kind of, especially when we didn't know exactly what our front end data was going to look like, it kind of allowed us to get our back end up and running, and then we could work on focusing on the front end. We also used Mongoose and MongoDB Atlas to access the database and to host the database, mainly because these were built specifically for MongoDB. We then use JSON Web Tokens and bcrypt for authentication. They gave us the necessary level of security that we needed for our app, given the data that we were storing. We then hosted our backend on Heroku. For our front end, we used React.js. Again, we had experience with this. We had a lot of ideas of functionality that we really wanted to implement. So we thought if we went with this, we could focus on getting all this, all the functionality in place. For our map drawing, we used Mapbox. We spiked a few different things, but we tried Google Maps and Leaflet, but we found that the docs were really good for Mapbox. There were a lot of usage for it. It also allowed us, they had APIs like for the static images and for the elevation as well. And on top of that, the draw functionality was really good, and we were able to be really flexible with that. We used Turf for for calculating the distances of the routes, and throughout we used Git for version control, and then we hosted our final product on Netlify. Now I'll just pass you over to Neil, who's going to tell you a little bit about the challenges that we faced.
Thank you. So, as a location-based service, our web app is heavily reliant on using an API. The beginning of our project and our first obstacle was learning to work with the Mapbox API. We quickly ran into multiple request errors, and not being able to view the structure of the database made it more difficult to pinpoint errors. We wouldn't have a solid database to start on without being able to request the necessary data, and in order to deal with this, we had 3 people looking into the formats which the API accepts, such as GeoJSON. So we decided to use a NoSQL database, which was better suited for our data, but this also meant learning a new technology. This was more of a challenge in terms of time. In order to continue working on our front end, we had to make sure our database was functional. Also, to speed up the process, we implemented paired programming, which helped with future backend related issues, as we have more members who understand and can help solve it. And for our final challenge, as expected, combining all of our code. On our initial merge, we had multiple conflicts, but since we have made sure to merge regularly and source out smaller components to be worked on individually, which helped significantly reducing conflict, and since we haven't had any major issues. I'll pass it back to Steph, who will talk a bit more about development.
So looking at our daily practices, as we've previously mentioned, we spent a good portion of our time at the beginning of the project spiking. So we wanted to make sure that both MongoDB and Mapbox were suitable for what we wanted to do, and that they also worked well with our other tech choices. So it was really important we spent that time doing that. Paired programming also played a massive part of our project. It was really important that we worked together, and as well, working on both the front and the back end in pairs meant that if another person hadn't worked perhaps on the back end for a few days, we would catch each other up on what we were doing, so there was no confusion on the code. Mob programming was also really important for us at the start of the project with Mapbox. None of us had ever used it before, so we spent probably around a day looking just at Mapbox, and we sat around working on that together before we branched off onto the project. We've also put a couple of images of our Kanban board. So we broke the whole task down into user stories. The blue tickets were for essential tasks, orange for like to have, and the pink were some of our back-end endpoints. And to use the Kanban board, we had twice daily stand-ups. So in the morning, we met up and we delegate tasks to each person. And then in the afternoon, we found it really helpful to meet up again, discuss what we'd done in the morning, if there were any issues, and maybe if we need to swap around. We've also mentioned about Git for version control, and it was really important. We found quite early that we sorted out communication in terms of using Git. We came into some quite big merge conflicts, so that was a really good learning curve, and then on we made sure we communicated properly using Git. And then finally, if we had extra time to work on the app, we would really love to develop a mobile app, as it would be great for users to have an app on their device where they could access the saved routes. Another thing we'd like to implement would be GPS. We did look into directions, but one major issue we kept finding was all of the directions were optimized routes, which is exactly what we didn't want, and the whole reason why we built the app. So we'll definitely need to look at that in the future. And then finally, if we can give our users any additional stats about the route, that would be perfect, like estimated time to complete the cycle or terrain, just because the people using it would like as much information as possible about the routes. So that has been our app Pedals. Thank you all for listening, and does anyone have any questions?